In this question, we have 2 satellites in circular orbits around the Earth. Satellite A, let's call this A, has a velocity VA, and satellite B has a radius 9 times that of A. So an orbital radius, so this is R, and this is 9R. Definitely not to scale. So then we have satellite B. We want to know what the V is. Well, we have circles occurring here, and we know that the force that in these circular orbits that's causing this is gravity. So we can just apply Newton's second law. The net force is the sum of the forces. And the net force is mv squared over r. And the sum of the forces are big G, big M, little m over r squared. So the velocity squared is equal to G, big M, little m, r, divided by r squared m. M's cancel, this cancels, and that cancels. And the velocity squared then is gm over r. So then v is the square root of gm over r. So if we have a velocity here at A, well, this is what the velocity is. And let's say this is the velocity A. So VA equals this. Well, if we look then at velocity B, that is also going to be equal to the square root of gm over r. But for our example here, it's 9r. Square root of gm over 9r. And we can bring out the 1/9 is the square of 1/3. So the square root of 1/9 is 1/3. And so we compare these. This is 1 gm over r, and B is 1/3 as much. So what is the speed of V? It is not 1/9 of what A is. It is 1/3. It is not more than, it's less than. And that's another way. We could start out by just asking ourselves, is it faster or slower? We could get to 50-50 in this case. So that is why it's choice B.